Hi, grade 8s. This lesson is on identifying prime and composite numbers. And before we do that, we're going to review what a factor is, because that will help us in our understanding of what prime and composite are. So factors are two numbers that when you multiply them together get you a bigger number. So for example, 2 and 6, when you multiply them together, get you 12. So 2 and 6 are factors of 12. Likewise, if we were going to list the factors of 9, well, 3 and 3 are factors of 9 because 3 times 3 equals 9. So now, when we're going back to prime and composite, I'm going to start with composite. A composite number is a number that has more than two factors. Okay, so that would mean, for example, if we did the number 12 and we were trying to list all the factors of 12, we would say, okay, so again, 2 times 6 equals 12, so 2 and 6 are factors of 12. 3 times 4 equals 12, so 3 times 4, or sorry, 3 and 4 are factors of 12. And then lastly, don't forget about the number itself. So 12 times 1 equals 12, so 12 and 1 are factors of 12, making 12 a composite number because it has more than two factors. So now for prime, a prime number only has two factors, and the only factors that it can be are the number itself and the number 1. So if we chose the number 13, the only whole numbers that we could come up with that when you multiply them together get 13 are 13 and 1. So when we're dealing with prime and composite numbers, we're only dealing with whole numbers. We're not dealing with decimals. So the only numbers that would give you, the only factors that would give you 13 are 13 times 1, so 13 and 1. So that's an example of a prime number. Let's do a couple more examples. So we are going to be talking about the divisibility rules shortly, and that will help you that when you see a number, if you don't really know the factors off the top of your head, it will help you understand, what it can be divided by, and that will help you get your factors. But for now, we'll kind of keep them a bit simple for this video. So let's just take the number 24. Okay, and we're trying to identify whether 24 is a prime or composite number. So let's list the factors. So again, we can do 24 and 1 because any number will always have those two factors. But then we have 6 times 4, we have 8 times 3, and we have 12 times 2. So you also want to make sure that you identify all of the factors when you are trying to see if it's a prime or composite number. You don't want to miss any factors because that would be an incomplete answer. And the way to understand if you've gotten all the factors is for some reason, if you didn't know your multiplication, you didn't know what numbers multiplied together to get 24. On your calculator, you could just do the opposite. You'd start by going, okay, 24 divided by 9. Does that give you a whole number? No, it doesn't. So you know that 9 cannot be a factor of 24. And then you could start by going 24, continue, I should say, 24 divided by 8. Well, on your calculator, it's going to give you the result of 3. So you know that 8 and 3 are factors of 24. So if you're dividing, you get a whole number, then you know that it's going to be a factor. Okay, so now we can identify all of these factors, which makes 24 a composite number. Now let's do the number 17. Okay, so if you know your multiplication, you could do this in your head. You can say, okay, what are all the factors that multiplied together get you 17? And eventually you would realize that the only factors of 17 that are whole numbers, only numbers that are whole, would be 17 and 1. because 17 times 1 is 17, and those are the only two factors of 17, which would make 17 a prime number. Now I like this little poster here. It goes over the divisibility rules, and this is going to help you identify your prime and composite numbers because you could do all of this on a calculator. Sometimes it's more time consuming, and if you understand the divisibility rules, it will really help buy you some time. Or not buy you some time, save you some time, I should say. So you know that a number is divisible by, so divisibility rules are how do you know a number can be divided by a particular number. So let's start off with 2, okay? So you know a number is divisible by 2 or can be divided by 2 if it ends in a 0, a 2, a 4, a 6, or an 8. So if you were given the number 48 and you're asked to list the factors, you would know right away that 48 can be divided by 2. So that 2 is going to be definitely a factor of 48. Okay, etc., etc. So let's now do how to know if a number is divisible by 3. You would know this if the sum of the digits can be divided by 3. So for example, if you had the number 294. So when it says the sum of the digits, the sum is going to be, if you remember what sum means, it's the answer to a question that involves addition. So adding up numbers, the result or the answer is going to be the sum. So you'd go 2 plus 9 plus 4. Well, 2 plus 9, 11 plus 4, that gives you 15. So the sum of these digits is 15. And can 15 be divided by 3? Yes, it can, because 15 divided by 3 gives you 5. So you know that 3 is going to be, you know that 294 can be divisible by 3, because you added up all the numbers, it gave you 15, and now we can work with 15. It's a smaller number, we know that can be divided by 3. Okay, going to the next rule, how to know if a number is divisible by 4, if the last 2 digits are divisible by 4. So for example, just gonna clear some space here. If the number is 524, okay? So now we're looking at the last 2 digits, which is 24. 24 can be divided by 4. So we know that 524 can be divided by 4, and which also means that 4 is a factor of 524. Go to rule number 5. We know that a number can be divided by 5 if it ends in a 0 or ends in a 5. So I'm going to work down here. 25 ends in a 5, can be divided by 5. 30 ends in a 0, can be divided by 5. We know that a number can be divisible by 6 if it can be divided by 2 or by 3. And sorry, I shouldn't say 2 or 3, it's 2 and 3. So if a number can be divided by 2 and 3, we know that it can be divided by 6. And if you think about it, that does make sense because 2 and 3 are factors of 6, right? So if it can be divided by 2 and 3, that means that 2 and 3 are factors of that number. And if 2 or 3 are factors, then 6 is going to be a factor as well. The ones from 7 to 12, I'll go over them very quickly, but I'll probably explain them more in class as well. 7 would be if you cross off the last digit and then you double it and subtract. So if the new number that you get by doing that is divisible by 7, then the original number is divisible by 7. For number 8, if the last 3 digits can be divided by 8, you know that it's divisible by 8. 9, if the sum of the digits are divisible by 9. So again, if you're adding all the digits together and whatever you get, if that number can be divided by 9, then you know that it can be divided by 9, that whole number. 10 is very similar to 5. So if something if it ends in a 0, It can be divided by 10. And 11, subtract the last digit from the number formed by the remaining digits. And then if the new number is divisible by 11, the original number is divisible by 11. So again, we don't really use that one too much. I find that most of the time we're looking at the divisibility rules between 2 and 6. And then 12, it is an easier one to understand as well. Because if you're looking at 12, if the number is divisible by 3 and 4, it's also divisible by 12. That's very similar to 6, because 3 and 4 are factors of 12. So if a number can be divided by 3 and 4, since 3 and 4 are factors of 12, then it's also going to be divisible by 12. Okay, and the question that I'm going to give you to practice is I want you to identify each of these numbers as either prime or composite. But again, you don't just put prime or composite. I need to see you listing the factors, and then I can see that you fully understood whether each number is a prime or composite. So you can't just put prime or composite. You have to list the factors, and you have to make sure that you've got all the factors as well.